Hello and welcome to Ovesen.net. I hope you are all fantastic. Today it's the fifth episode of this series where I build this Commodore 64 motherboard. In this episode I hope I can finally turn the power on to this board and see if it actually works. Anyway, here it is, the almost completed KU motherboard. The KU14194HB made by bwack, he designed this replica. Before you see this episode, you should probably see part 1 through 4, where I show all the progress in this series. Now, there is just one thing missing on this board, besides the CPU, which is currently in another machine. I need a solution for an RF modulator replacement. But I'm not actually going to use the RF signal on this machine. I will use just a composite video signal going through to SCART or S-video. So I got this C64 RF modulator replacement from a seller on eBay from Finland, and it's based on this GitHub site here where I can't pronounce the name, Embarsis PCB C64 RF modulator replacement. This modulator replacement should be compatible with all Commodore 64s and provides high quality S-video. So take a look at this. And here is the actual kit. It was sent to me like this with all the different components taped onto this paper, and this is the neat little PCB. Looks very nice. And it's all true hole components, so no need for SMD soldering. So next task is to actually build this and add it to the board, and then I'm ready to test. So this should be a fairly easy soldering job, so let's get going. I start with this pin headers. Then a couple of trim pots, and these look similar, but they have different values, so be aware of that. Final pieces is a diode and a couple of resistors. I just double check the resistor values. I'm not very good at reading the values of the color bands. So this should be 1K, and this should also be 1K, and yeah, almost. That was the soldering on the upper side. No, just these pin headers on the back side that are supposed to be soldered onto the Commodore in place of the RF modulator. So that was the build completed, and now I'm just gonna clean everything up, remove all the leftover flux with some isopropanol, and yeah, good to go. Then you simply place this little RF mod into the holes of the original RF modulator and solder it onto there. But to keep it a little above, I need to put some, yeah, I put a little rubber foot like this. I think fits there. Not completely level, but I think it's okay. I'm gonna cut a little bit of this one so that it gets level. There, now it's quite leveled with the motherboard, so I think I'm good to solder it in. Alrighty. This board is completed. Now I'm gonna test. So this is the moment of truth. Can I get life into this board? Before I start to test it for real, I'm gonna remove all the different chips so that I can test voltages, things like that before I use the chips. And that's because I don't want to risk damaging any of the chips if by accident, for example, I get 12 volts into the 5 volt rail or something like that. IC's removed and ready to power on, and for the power supply I'm gonna use this one. It's a brand new Commodore 64 power supply made by Keylog, and yeah, this looks really nice, and it also has a OLED display displaying the output voltage and how long you have had that on, and you can also, yeah, I don't know what this is actually, but it shows some other information, or you can turn it off. Okay, it's in. I'm gonna turn it on now, and then I'm gonna check and see if I have the correct voltages, and also feel that nothing's getting hot. Alright, did not explode or start a fire yet, so that's a good sign. First thing I'm gonna measure is that we have 5 volts across the board from the power adapter, and yeah, for example, to the cassette port here. So starting by that, and just find the ground point somewhere, and then there should be 5 volts on that pin there, and it actually is dead on 5.02. Then I'm gonna measure the voltage regulators. This one is the 12 volt, I think, and it has 29 volts input and 12 volts dead on, yes. Next is the 5 volt regulator, and it's over here, and it should have, it has 4.94 volts. The VIC chip also needs a 5-volt input, and I think it's one of these pins here. Okay, it's that one. That's the one. 1204 volts, and that's exactly the same as this voltage regulator gives out. So yeah, perfect. Then the RAM should have 5-volt input on pin 3. It does. Let me try everyone. Okay, checks out fine. Now this is not under load, so not much current is drawn, but the 12-volt regulator is a tiny little bit hotter than room temperature, and this 5 volts is not at all. And yeah, I can't feel heat anywhere, so I think this is actually good to go. One final check. I already checked all the other sockets, and they all have the 5-volt. So the SID chip is here, and it should have a 12-volt input. So let's try that. Yeah, 12.04, exactly the same as out. I am pretty confident that this board works okay power-wise, so I'm gonna repopulate all the chips, but I actually got a couple of new chips in, and it's the color RAM and also the MC4044P, which is here. And yeah, if you remember from my last episode, I found a couple of those from old machines, but these are actually yeah, new or unused old stock, so I'm gonna use those. And I got a couple of spares too. This is the color RAM, and it's a Sanyo, and it has a little bit different serial number or model number than the original, but hopefully it will work. And the MC4044P is the original Motorola chip, so it is going... Where is it going? Here, I think. Alright, then I'm gonna insert all the different chips, and be exciting to turn this on and see if it actually works. I have my hopes high, but I am realistic that the probability that it won't power on at first try is high, so yeah, we'll see. Finally, the CPU is going back into its socket, so then this board is complete. Now I just need to find the correct jumper settings for the RF modulator replacement, and yeah, I'll go to the GitHub page, take a look. According to the documentation, since this is a long board and 12 volt, then all the jumpers should be set on top, on the upper pins. If this was a short board, a Commodore 64C, then the jumper should be down on the other pins. Da, 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 da. So what are we waiting for? Plugging in. Turning on. As I said, I'm prepared that it's not working and I won't be disappointed if that happens, but okay. 3, 2, 1. Look at that! Fantastic! Worked on first try, actually. So I'm really happy now. There is a slight problem with the picture. It is jumping a bit up and down, and these light bars going over, but that's probably some adjustment on the RF modulator. So the 5-volt regulator gets very hot after a while, and I can't even touch it without burning my skin. And after a while it actually breaks down and starts reducing the voltage. Now it's on 4.9 volts. Let's see what happens. So there you go, now it crashes and starts dropping the voltage. So I guess the 5-volt regulator needs some heatsink, and normally it has on this board, but the placement right here is not ideal for adding a heatsink. When I searched for photos of the actual original KU motherboard, you see that there is a large heatsink here on that regulator. I don't have that, so I need to make something similar. I actually got this heatsink from another Commodore board. It's not similar, but I think I can maybe bend it so that it can be used and then drill a hole or something. I don't know if this aluminum is hard enough that it can handle bending it back. So this might fit, I think. Something like that. And then I need to drill a hole. Now let's see what we can do. I got a hole in it, and I have a little thermal paste, so yeah. Oops. Alright, heatsink is on, and I added a lot of thermal paste between, so hopefully this will be enough. Okay, with the heatsink things are looking better. I had this on for quite some time now. I'm running the diagnostics cartridge now. So the heatsink is actually quite warm. I can't touch it. I'm not sure if that's normal or not, but I'm gonna check with another computer. The diagnostics cartridge seems to run most tests okay. Few are bad, but I didn't add the test harness, so I think that's pretty normal. And the SID chip is actually producing sound too, so looking good. Now about the white distortion that scrolls down the screen, I actually talked to bwack, Hans Petter, and he told me that this was because of the modulator board was not grounded. Alright, let's test. I just have a little wire here. I'm gonna touch to the ground pin onto the board and see what happens. Okay, yeah, that really did it. He also told me that to ground the modulator board, you can just put some solder blob onto the PAL-I solder point. put the board into its case. I actually realize now that I have a slight problem, and yes, this case requires that the keyboard sits on top on the motherboard, resting on some brackets, and I don't have that. So I have to find something from another machine, or I have to find a model and 3D print some plastic parts. I found these keyboard supports on Thingiverse. They are for Commodore 64Cs, but they might work, or I can maybe modify them to be used on this machine. This is the actual keyboard I'm gonna use. This is a keyboard I recently restored and cleaned inside and out, so I think this will work very well on this machine, hopefully. So I think this one will be nice on this machine. I like the white keys. I printed the keyboard brackets, but as expected, they don't fit very well to this board, and especially on this side, they don't fit at all. And yeah, you have this heatsink in the way anyway, so I have to come up with another solution. I'm adjusting the mounts a little bit so that they can fit better onto the board. Alright, that will fit on this side. The other side is more difficult. For the right side, I actually took this part and I mirrored it, and then I printed again. So now I have this mirrored part, and I just cut a little bit of one of the legs here. New hole in place, and this seems to fit perfectly. So screwing in that screw. Okay, I think that's it. Ideally, the keyboard stands should be secured to the motherboard by screws, but there is no screw holes there, so I think this will hold nicely. I'm not gonna use this machine that much after all. Not typing, at least. I'm gonna add another heatsink here, just to be on the safe side, so yeah. Then finally the last 3 screws. Alright, that is the machine completed. Case looks okay. I think it's yeah, not the best case, but that's what I have now. I might shift to another case later, the bread bin case, just to get the keyboard properly attached to the machine, but I think this will work. I was thinking about putting a little personalized badge on this machine. What do you think? Should I do it or not? Give me feedback in the comment, and I'll see what I do with this. Now it's time to load a few games, see if they work. So I hooked up my Pi 1541, which is 1541 floppy disk emulator, and I have a memory card in that where I have yeah, most Commodore 64 games actually. So game to test with. I'm thinking about Mission Impossible, or is it Impossible Mission? So I'm sorry, I'm filming the TV here. I haven't really gotten a capture device, so I had one from China, but it was crap and I can't use it, so I have to film and then see if I can find a good capture device. Loading time is still very long, even if it's a Raspberry Pi, so yeah.
Another visitor. Stay a while. Stay forever.
So I was a bit concerned about the sound, but seems to be working just fine in this game, and the speech synthesis was quite normal. However, there is some noise coming from from the audio. I don't know if that's from the SID or some other distortion, but yeah. All right. So the audio is just fine. For my ear, a little bit noisy, but yeah, the SwinSID is working fine. There are a few artifacts on the image. If you see up here by the P, it sometimes shifts color, and also a little bit of color bleeding here, going up and down. A little Super Mario. Let's try the morning shift for beginner. Oh man, yeah, that's really it's a simple game, but it's quite fun, and I remember I was stunned by the speech, and yeah, lots of levels, great game. So it was a very exciting project, and really exciting the moment when I turned the machine on for the first time and saw that it actually worked. I have a few more ideas about this machine, but that will be for other videos later. For now, I'm just gonna test it more and improve the things that I feel needs a little bit more attention. So I hope you enjoyed this series and would like to see more videos. If you haven't already subscribed, then just subscribe, and I try to produce a new video every 1 or 2 weeks. So some of you might wonder how much building this machine actually cost me, and I used a lot of good quality parts and components from Mauser, and with shipping those were not cheap, and also got a couple of other shipments, and I have the plankton PLA and the swing seed and the power supply. So I think total amount I have used is about 350 euros. Alright then, thanks for watching, bye bye.